Hey everybody, Dave Lindbergh, another episode of the THD Podcast coming to you from Hong Kong with our co-host in Japan, Simon Weston. And this week's special guest is Mr. Harald Obereder, who is the general manager of Emporia Mobile, who specialize in senior phones. So we thought it'd be interesting today to kind of talk about how the development process works for speakers and such within mobile phones, and then maybe a bit of what's special about designing speakers and audio inputs into mobile phones. So, yeah, Harry, please go ahead and introduce yourself. You've been in China for some time, so tell us a bit about how you ended up here in Shenzhen in 2020.
All right. Thank you very much, Dave. Thanks for inviting me to your podcast. Thank you, Simon. I'm in China since 13 years now. I came 2007, and basically at that time, that's the time when Apple also started producing their first phone, and that's when we started to make our phones. And our phones have a very, very clear target that is senior people. We actually try to make easy to use phones. So it's not just senior people, but they have the most benefit. And that's what I have done the last 13 years. And I'm happy to share some of the learnings we did.
Hey, Harry, can you just give us a quick rundown on what defines a senior phone, just for people like me who aren't all that clear about it? What is a senior phone?
So most people think about it just like, oh, you have big buttons and a loud speaker, and that's what the senior phone is. But I mean, of course, it's the older you get, you will lose some of your dexterity, you will lose some hearing, so you have to make it. The audio part is what we talk later about. On the haptic feeling, you have to make it a certain size so it's usable. You have a clear feedback, but that was on feature phones. We usually have also an emergency button that links you up with a call center or with your relatives. But smartphones are becoming more and more important also for our target group. So actually the most important now, I would say, is a very consistent user interface. So when you have your standard Android or a standard Apple phone, then you have different levels. You have horizontal, vertical scrolling. You have hidden features like long press, swipes, and whatever those guys come up with. But that's not easy to understand. You cannot tell, for example, your mother. It's not intuitive for her because she didn't learn it as we do it now, right? So a very consistent user interface. If that would be a complete topic by itself, but simple put, if you take my phone and you go into the phone app to make a call, or you go into the gallery, or you write an email or a text message, or you go into the settings, you will find yourself in the same basic user interface. So that nothing is hidden. The most important points are on top. The back button is always on the right side. There's only one way of scrolling it vertically. Everything is always in the list view. And basically, if you're familiar with one of those apps, you can handle all the others. So, for example, there's no difference between writing an email or a text message on my user interface. So the consistent user interface, we design our own fonts even, especially on the feature phones before, because you were limited on the screen sizes, right? So we had to make sure we have a very good readable font that is. We literally designed all the ASCII signs by ourselves. So lots of things. And of course, on the other side, we did a lot on the audio side, and that will be the topic for today, because I don't know if you know, guys, probably you know, but we are all over the peak of our hearing already. That's usually between 80, early 20s. That's when you're on your peak, and then from then it's going down. So
okay. So So I guess there's a process between like understanding how people's hearing declines, and then is there an actual specific process you go through to design the speaker, or I think you actually call it a receiver in telephone industry. What we call a speaker is a receiver for you guys. And what do you do?
Let me.
Yeah.
So that let's say that's one of our flip phones. Okay. That's a smartphone. This is what we call a speaker, the loudspeaker when you go to hands-free. This is what we call a receiver. So the one that goes on the ear is called the receiver.
Okay.
The one that you use for hands-free is called a speaker in the mobile phone industry. Or that's how we how to say. Yeah, most of the mobile phone industry is in Shenzhen or Guangdong. That's how we call it here. Might not be the technical term because you also call it driver and transducers, and maybe Simon can talk more about that. But to be simple today, let's call the thing you put on the ear is the receiver, and hands-free is speaker.
Okay. So I think at the beginning, most people would still use the receiver part to listen to calls. It's becoming more prevalent now that the speaker is used for calls. So what kind of effort goes into designing the receiver box as a transducer element?
I would say the effort is similar for the receiver part and the speaker part. Both, of course, you have to choose your receiver first, right? We usually go for a very low resonant frequency. The lower, the better. That has something to do with hearing loss. Maybe I have to talk a little bit about hearing loss first before we go into the selection. So usually the older you get, the more first you lose the higher frequencies, right? And the normal, like the normal style phones usually go from 300 hertz to 3,400 hertz. There's some wideband or high HD audio, but it's still not as widely used as many people think. So let's say that's our cutoff frequency, 3,400 hertz. We try to bring the resonant frequency as low as possible. So that's the most important criteria for the selection process. Of course, the power has to be okay. We have to make an optimized speaker design with the right volume. That's why sometimes it's not that easy to fit it in, right? Because you have to get the volume somehow or somewhere. That's why we don't have the thinnest phones probably. So basically that's the first step what we do, and then the second step would be, I mean, we have over the years we made a lot of different designs, and we found a few things, especially for our industry, work quite well. So, for example, we have a very simple hearing test on the phones that you can measure your audiogram by yourself. So basically, we play pure tones at different levels, different frequencies, and then you have to press a button or OK or touch some.
Oh, a little bit of trouble with the connection. Hold on a sec, guys.
Where were we?
Talking about the ability for the user to detect what they hear better and then select their preferences.
Yeah. So basically, we measure the audiogram. We have some predefined audiograms where you can just go through. But if you want to go through the process, then you have pure tones at different levels, different frequencies. We define the audiogram, and based on that, we would change actually on a software side the frequency response of the speaker. Usually the frequency response of a speaker is just, you try to have it as flat as possible over a very big, over the whole frequency range, right? So that's given from the how the speaker is basically made, and that's what they try. But ours, we would try to amplify the bass more than the higher frequencies. It's also because how to say, we have more, as the older you get, and the probability that you lose the higher frequencies is higher, we focus on the lower frequencies. That doesn't mean that it wouldn't help if we have higher frequencies and we bump them up to, I don't know, 90 dB, so they can hear it better. It would not help, but it's easier to focus on the lower end. And the how to say, we do a lot of tests also, and we did a lot of tests in the past, so we had the better results with that.
Okay. Now, in a production application, will you be testing each speaker to make sure it falls into line before you assemble it into your phone?
Actually, we do. Yeah, we don't do 100% test, but we do. You call it AQL. So you out of 5,000 speakers, for example, that's one production lot. You draw like 200 speakers, and then we have a measurement equipment that basically checks the frequency response.
Okay.
Measures it.
Is it like some of the classic vendors of mobile phone speaker modules that you guys might deal with, or maybe you don't want to tell us, but like the big guys, basically? Yeah.
Yes.
Okay. Interesting.
So we don't design our own speakers or receivers, but we carefully select them. And it's, for example, when you talk about senior phones, then on the receiver you have another part, which is the HAC, the hearing aid compatibility. I mean, every phone should basically support it, but of course we, as this is our target group, we really take care of this. So that's a second major criteria which we go for, because a lot of receivers don't support that, and it's only important for the receiver part, because that's the part you put on the hearing aid, right? So the speaker doesn't need to have a HAC rating.
So is that related for like a user wearing a hearing aid? If they couple the phone receiver, they're not getting some kind of feedback loop created between the hearing aid and the receiver speaker of the phone?
Yeah, I mean, there's two things, right? A hearing aid can usually work in two modes. You have the T-coil mode, which is a telecoil, which means if you use that mode, then the microphone of the hearing aid is switched off, which means there's no acoustic input. The input only happens through induction. So it's the phone, the receiver of the phone will either be prepared to have enough inductive output. So that means the coil has to be designed in a special way to create this magnetic field, and it will directly communicate with the T-coil of the hearing aid. And in that way, you don't have any noise. You really just have the pure signal. And then and you want that rating always high. So we usually have the highest rating for our phones, which is M4, T4. T is for the telecoil, and M is for the microphone input. If you go on microphone, that means the receiver goes on the microphone of the hearing aid, right? And then it's important that you don't have all these unnecessary signals or noise, and that you don't have interferences with the RF parts of the phone. And sometimes it's like charging that's close to a frequency we can hear, right? If you have some noise on this. So that's a very, very big part, actually, going through testing, design, and certification to make sure that those ratings are up. So the M rating and the T rating, we usually achieve a high rating for them because we know how to design it. Sometimes if you have we also have different materials, right? This one is a normal glass, but sometimes we use metal, especially for smartphones. It gets more and more popular, and then you have a problem with the T rating, because then your magnetic the induction is not working in the most efficient way. So what we do, and what we've done in a few models, then we would take an extra small coil. You could get as a speaker without membrane and magnets, and we just place it in parallel to the speaker. But of course, it will take away from the power. So you have to probably use an external power amplifier, because the normal mobile phone chips are not rated for that output to drive that.
Just wanted to ask a little bit more about the low frequency thing you mentioned. I don't know if it's proprietary for you guys or not, but anyway, you said typically they're running 300 hertz up to 3K, and you try and extend that low frequency as low as possible with the driver, and then by whatever EQing at the end of it. How does that relate to the speech intelligibility or the benefit for older people? What about it makes that important?
So there's two things. One thing is that people can hear, or older people can hear lower frequencies better than higher frequencies, because they already lost. Like it has to do with the hair in your ear, basically. So the ones that detect the lower frequency, the higher frequencies, they die first. Let's say it like this, and that's why it's important to focus on the lower frequencies, because that's the area where most of our customers still have better hearing, right? And also, like, if you go we also did tests and we implemented it some and there's like some things that you can really make. You can make speech better by slowing it down. Some parts don't work like this. For example, and vowels, which are like more lower frequencies, are more easy to hear than consonants like S or this kind of things. So if you stretch it a little bit, you make them better understandable, even with the same level. So yeah, that's quite a challenge, because if you stretch sounds, right, or if you stretch speech, at one point you have to keep up. If I keep talking like I'm doing now, and I don't make any pause in between, then eventually I will like not be able to do it in real time anymore. But usually in a conversation, sometimes I talk, sometimes you talk. We have some pauses in between, some natural pauses. Then we have some, like what I just did now, searching for a word, or or and then those parts we use to catch up again. So, but there's really a lot of signal processing involved. It sometimes works quite well, and we're still doing a lot of research in that area as well.
Is that something that's special for you? Or is this? I can imagine that almost every phone brand wants to have clarity to the understanding of the speaker. But is this something that your brand focuses on, especially because of your target market?
Yes, I mean, you have all these tier one suppliers. They want to have very clear audio, but their target group is not necessarily like 60 plus, right? So they don't focus on this. I haven't seen it in one of the big brands, to be honest. It's the same with user interface. They focus on their main target audience, and seniors are not really in there. So for usability, Apple actually always took more care on usability, but Android was terrible, still is terrible. Even Apple. I mean, imagine before when you pressed the home button on an iPhone and everything started shaking, right? So that's like a nightmare for a digital, how to say, a non-native. They don't know what's going on. There's so much like surprises happening during the usage of a phone, and then every app looks different. And then you have so that the same, and Apple did, but because they are a more design-focused company, so they took more care that they basically clean up the home screen, make it a little bit more sleek. But that doesn't mean that they made it easier to use, because like the hidden features you have, when you have a message and you do a swipe to make it, to delete it or unread, so those are things, they are not intuitive, they have to be learned. And if you don't have anybody who teaches you, then it's really difficult to do. So that's why they never focused on this. And there's not many companies which really focusing. And I would say Emporia is probably the first one who really did it in a very good way and a very focused way. And the same is what we do with audio. We are really focusing on this, and it's not on the, I would say it's not in the focus of those big companies.
Is there issues that you're presented by having apps on your phone, like perhaps grandma gets advanced enough that she's ready to use Skype or do a WhatsApp call or something?
Yeah,
or
WhatsApp. Yeah.
But do those apps feed you a lower quality of audio that you then have to tackle with in processing, or is there a standard to what they spit out?
So there's two different paths in the mobile phone for audio. Dave, you're breaking up. I can't see your video. Can you still hear me?
Yeah, I'm here.
Okay. So there's basically two parts. One is the native calling path, I would say, that runs via the modem, and then there's all these IP calls with WhatsApp or Skype, and especially with background noise, with noise reduction, you can have problems with that. Like a lot of phones have a second microphone for that noise issue, right? But on IP calls, that very often doesn't work, depending on the app actually, because it cannot access the same audio path as the native phone itself would access. So yeah, there's some problems, and I can, how to say, you have to live with this kind of things in the moment.
The signal processing that you're doing, is that a separate subsystem that you have in the unit, or do you use the main processor, or do you use the, for example, the Android OS to build software, or is it a separate
on Android phones? On Android phones, yes, we do. So we do use, because the processors are much more powerful than the processors we have on our feature phones. On the feature phones, it was actually, for us in the beginning as a small company, it was really difficult to get to even get access to this kind of to the signal processing unit inside the chip, right? So we had very good friends at different companies. At that time, it was still Infineon. Now it belongs to Intel, who made one of the first processors where we really opened up and we did the audiogram. And usually at that time, this was like 10 years ago, more than 10 years ago. And our volumes were still low. That was actually actually really, I have to say, great of them to support us, because nobody else has done it before. They told us, no, we don't support that. And we said, why? Because nobody has asked that before. So they had no SDK, no developer kit to do that. And I just, how to say, kept on asking, explained them what we do, why we need to do that to make it better. And they were really understanding. So like, yeah, I think nowadays, really difficult. If you're a small company and you talk this to the big chip suppliers, Qualcomm, for example, they never helped us on anything related to that. That's the reason why I don't use Qualcomm chips. The Taiwanese supplier MediaTek was actually quite open, as I said, Infineon before it got sold to Intel. And yeah, and nowadays our phones get also upgraded processors, so it's not so important to crack down on the signal processing unit directly, or a lot of them have options already.
Yeah, and maybe to give people an idea, like, I mean, for audio world, like headphones and stuff, like a 50 to 100,000 unit product run, what kind of volumes would we be talking about for the senior phone market?
Well, we are around 800,000 units in the Corona year this year. So,
okay. And is this a worse year than normal?
Yeah, a little bit worse.
Oh, really?
But
I hadn't heard. Okay, no, that's just interesting.
But not bad,
yeah.
bad. But it should give you an understanding that I mean, if everybody would do it, then you would have interfaces, APIs for these kind of things to do, right? So it's actually difficult to get these things done, especially on lower end phones. And on Android phones, there's like on no new smartphones, they're so powerful, you can do a lot of stuff.
So there's a lot
Can
of...
I ask a little bit, sorry, I just wanted to ask a little bit, how does it actually stack up in terms of the structure of things? So an ODM or an OEM actually builds the phone, you spec out parts, and you focus on the software, the firmware element, or how does that actually work out? The split between the assembler and your company, I should say.
It depends. So I started out doing everything in-house. I did I made the schematic, the layout, the antenna design, then the mechanical design, industrial design. Then I found suppliers for the mechanical, which is the housing, let's say like everything you can touch here, right? They made a tooling for me. Then I bought every single component, every resistor, every capacitor, every chip, everything what is on there, and brought it to an SMT company, the SMT, and then I brought all the other components, display, battery, mechanical parts, packing, user manuals, everything you need for final assembly to a final assembly company, and they did the assembly. So basically everything except the manual labor I did in-house. And then that was 2007, the years passed by, and at that time it was really difficult to develop a phone actually in Shenzhen. Now everybody knows Shenzhen is like the capital for mobile phones. Everybody's producing here, but at that time there was the big companies like Foxconn, they could do it, and they did for Apple and for I don't know, HTC or the brands that were around at that time, LG. Nokia was doing big with BYD actually here, but they wouldn't talk to me, right? Those big companies. Mm-hmm. Because
it's kind of incredible. You went almost totally vertical right off the bat, rather than trying to do a component or sell somebody some IP firmware or something. You did the whole thing.
I had a head start because I had the right university degree for that. So basically, on the first processor that I used in one of the first phones, I was developing part of the process. So at that time, for a company called Dice, it was still during my university time, and Dice was a subsidiary of Infineon, and they made the ULC platform, which is an ultra low cost platform for feature phones. So I basically understood like everything from bottom up. I knew how to design antennas. So, and I built up my team in that way. And over the years, that's what I was going to say before, it became an advantage to just do the design and outsource like hardware, because if I buy, let's say, 500,000 chips a year from that certain chip or that certain resistor, 1 million pieces, or the LED, whatever, then I get a good price. But a dedicated design house who does just hardware, they probably have 50 times the volume I have. So if I want to compete on pricing, I have to be smart on outsourcing. And again, in the beginning, it was difficult to design a phone, so I kept it in-house to design the hardware. But as it became more mainstream and the chips became more integrated, and it's not so much like magic to make it work without that you have the TDD noises and all that stuff what we had before. I gave more and more for the parts where I didn't feel I lose IP or I lose know-how. I gave it to design companies who are specialized on that, to sourcing companies who do nothing else but sourcing mobile phone chips all the time. They have stock. They do the export with the how to say, the VAT export with Hong Kong. They are much more streamlined for that, and that helps me on the cost. I keep all the software still in-house, and that's why most of my people are now software people, actually. So that's where I feel our value is, and yeah, that's what we develop in-house. So basically, now we have a hardware design company. We spec it out, so we say how it has to be. We do the control drawings, which means the size and everything. We define the processes. We design basically everything, but then they make the layout for us, produce it, and already send it to us with all the, let's say, 300 components that are on it to me. And before I had to buy all those 300 components, and I had to have my own warehouse, keep stock, and yeah.
Wow. So it's almost like we've seen that you've been through the kind of whole process of the cost down of mobile phone manufacturing, in terms of you do it all yourself, and like as Simon said, very vertically integrated, to now kind of realizing where you're losing your advantages in purchasing power or engineering power, and just subbing that out. And then, so this kind of leads into a question here, is like, you've mentioned that you're focused on your software development team. Where else do you see the mobiles going? Will you move into like wearable devices, or stay with a handset? Where do you kind of see your guys going, both hardware and maybe some software insight?
So I would say we still have 100% focus on handsets.
Okay.
I experiment with very variable devices every now and then, also with medical devices all from time to time. Variables will only be really useful if there's a major battery breakthrough. And I don't want to design products that land in the corner very fast. So I'm not satisfied with what we can do on variables in the moment. So that really needs a battery improvement. But I have done a few variables over the time already, which includes like emergency watches that are connected to the phone, so you can make a remote emergency call. And actually, I mean, the technology is there that you have a really nice device on your wrist, but if you have to charge it like every day, in order to keep it running. That's not a use case what I need. So usually my mobile phones, they're not, our customers, usually they're already in retirement. They don't use them so heavy. They're also not so as addicted as we are. But my phones are usually, I would say, you can easily have them for a week without charging.
Wow.
Smartphones with bigger screens, you go 3-4 days. I mean, I don't know about your phone, Dave, but I guess you charge every day. You are a slave of your phone, and that's literally. I mean that actually, right?
Yeah. No, there's a lot of discussion on this topic in psychology as well.
I try to make the life of people easier, and I don't want to give them another device which they have to babysit basically, and which they have to take care of. So if I go into variables and there are some plans, then I'm talking about at least a year of battery lifetime. So that's a very specific use case. We are getting there also with LTE, low power or low energy.
Okay.
Can I just jump off topics ever so slightly? But given that we now found out that you know everything about phones from the bottom up, what's going on in terms of data collection from a Google operating system? Is it transparent, or are they collecting data that users don't know about, essentially? And how much can you control that as a firmware implementer?
So actually, it is very transparent what they are collecting, because whenever you buy an Android phone, then you basically agree to the terms, and if they update them, they will even send it to you again, and then you have to agree. But nobody reads through it, of course. There is a lot going on. So basically, every phone has an ID which cannot be linked to your name directly. It's more for an advertisement. It's an advertisement ID, right? So they can match this ID with apps you download, with cookies you get on a browser. So this is pretty powerful. And actually, for a free operating system, I'm not against that. Somebody had to put in the work to develop Android, and Android is great. It changed like how we, not just Android, Apple as well, but Apple is a closed system, and Android did it for the masses, let's say it like this. And to be honest, to a certain degree, I'm okay with that. They have to monetize it somehow. They have to earn money by using the data in a smart way. It's not that easy, to be honest. I mean, you can collect data, but to collect data that is not linked to you as a person and still make money out of that, that's an art for itself. So yeah, I'm not supporting it, but as I'm using Android, I'm okay with it. It helps us all together.
So I guess as a follow-up question to Simon's collecting the data question is, are they listening to what we talk on the microphone and also what we're listening to from our conversation on the other end?
No.
No? Okay.
At least in my 13 years where I'm in the topic now, and Andrew is around for a similar amount of time, I haven't seen any clue on that. So there's actually a few years back, somebody asked me what I think would be the next step for like mobile phones, right? Or what is the like mid to long term outlook? How can these devices really help us? And one thing is, of course, speech recognition, which is getting really, really good for native English speakers. For me, in my Austrian dialect, it's not really that helpful yet, but it will get there. It just needs more data. This kind of data they collect, but it's not. They do a speech processing with it, and then they match it to a text, basically, right? So that's, of course, they need to listen to that. But you agree to that, and they won't use that kind of data to listen into you. But what I found quite interesting is that this kind, and actually Amazon is almost there. So when I talk to you, Dave, and we know each other now for quite some time, you know if I'm upset or if I'm happy or if I want to go out. You know me, right? Yeah. And I know you. I know when I hear your voice. So phones know so much about us because of that, because you talk through the phone the whole day, right?
Right.
Together with probably a normal heartbeat reading or ECG, you can actually, out of the voice, out of my tone, you can read so much, and that's where I think it's going also. So it's like really like it would tell me and say, Harry, take a break, slow down. It's like this more than personal assistant. And I just read, I think it was 2 weeks ago, that Amazon came out with a wearable device that tries to do something like this. So
yeah, their little wrist device they launched.
Halo, they call it Halo, I think.
That's right. Yeah.
I find this very, very interesting, and really, yeah. A few years ago, I gave that as an answer where it will go in mobile phones. Also, screen sizes will be like, I mean, we maxed out. I don't believe so much in the foldables. I like the new Motorola, like basically a smartphone that you can fold like that, right? But I don't know. So and for that, so in order to have that, it's really important to have good microphone, because it really needs to analyze your voice.
Mm-hmm. Yes.
Not just transmit it, but really have a absolutely high accuracy and sampling rate in order to filter out if you feel good today or not, or if maybe something else is going on. I think it will be able to predict illness, if you get sick, if you have stress. It can be really, there's so much information in that. It's like talking to a good friend who knows you well and say, hey, slow down.
I actually believe this all leads into like the health and wellness industry, and then I can believe Amazon becoming the world's largest insurance and health supplier, because they actually have this kind of instant, not only instant feedback, but they have this massive data set over like how you're doing throughout a day. Like if you're wearing your device for 12, 16 hours, the data pool is so much more accurate than even if you go to the hospital or you visit your doctor once every 3 months, or that would be a high frequency. Most of us might go to the doctor once a year. So yeah, you can kind of see.
In my case, never. I don't remember. I go to the dentist, but I never go to the doctor.
Right.
Because I listen to myself, I listen to my body, and basically if you have a phone that it's trained on that, but then you have, people are addicted to these kind of things. They have to measure everything nowadays. Like you know it, right? I'm not that kind of person, but if there would be somebody who tells me, who gives me a hint from time to time, I would accept that. And I think that's where it's going, and that's where the quality of what we put into our phones is even more important.
Yeah, so I guess in summary, what we could take away from this is that the ability to use audio as an extra sensor in terms of determining the wellness and everything to do with the user is kind of a key thing, especially in the senior category. If they're feeling a bit blue or sour, you can be able to detect it in their voice, and then apps could make alerts and stuff like that. So I think that's quite a bit of information for one afternoon. Simon, did you have any other questions?
No, I think they covered it very well.
Okay. So I guess Harry, would you like to add anything as well?
Just that to your last point, for example, before you not 100% if this is correct, but before you get a stroke, or if you have minor strokes before a stroke, your speech can be like slurring or so. These kind of things you can easily...
Like right now on Zoom?
Yeah, like exactly right now on Zoom. Definitely that can be, I think that will be huge. And of course, those big companies who have more data over it, they will be the biggest beneficiaries of this. But I think even smaller companies or startups, if you focus on a point, that's what we also did. If you really focus, you can make a great business out of it. And even if it's difficult, I told you how difficult it was to like get the open the black boxes of Infineon and Intel to get down. On the other side, you know, when you bring a mobile phone to the European market, that's our main market, you have to do certifications like GCF. Or I mean, CE is actually quite easy, but for GCF, if you have to do the audio measurements, and some operators believe they even have to put this one step further, and they have their audio requirements, and they then often don't really understand what we are doing. And then my spec is outside of their narrow tunnel they want to have for the frequency response, right? So I had to do a lot of explaining until they accepted actually what we are doing and why I'm not in their specification, inside the specification. But it was not just doing all these audio things, it was really also building up senior phones as a product category. So I think Emporia has done a lot in that field.
Right. Okay. Well, let's call it a day then. So I'll just thank Simon coming in from Japan, and of course Harald Obereder, the GM of Emporia Mobile. We didn't really say it clearly, but they're an Austrian company and Harry runs the office in Shenzhen in China. So I guess thanks everybody, and if you like what we're doing here, please don't forget to subscribe to our channel. We're doing this every week. All right. Bye everybody.
Thank you, Dave. Thank you, Simon. Bye-bye.